Hello everyone, my name is Victor Gundele and I welcome you to Time Out with Victor on financial modeling. Today we'll be discussing something called debt funding in project finance. Now, why is debt funding so important in project finance? If you want to embark on a typical special project vehicle, which we call SPV, you need to understand that most time it's being funded with 80 or 70% of debt. So which means you have a 70-30 debt to equity ratio or 80 to 20 equity ratios. It also depends on the project. And as such, you need to be able to model out the debt because almost 80%, 70% is compared to equity. So which means for someone, this is a typical project that has no historical financials, they've actually not done anything, right? And you want to commit as much as 80% debt. And the interesting thing about it is the project that will also generate the cash that you're going to use to pay back. So which means you must be able to model out the debt very well because it definitely have different covenants, different constraints, different agreements, different factor that you need to build into this your debt funding in project finance. So we're going to keep it simple and then we'll take it to the next level and also consider different factors that you must consider whenever you are building your debt funding. So the first thing is what we call debt schedule, right? Debt schedule. So no matter how complex the terms of the debts are, right, you must always know that you still need to maintain this debt schedule. And we have one simple acronym that we call BASE. Call it BASE. That is an acronym. So which means B stands for beginning balance. I always know that beginning balance for any period will always be the closing balance for previous period. Let's assume today's January 1st, and I'm asking you what's our opening balance for January 1st? Definitely that will be what? Our closing balance for December 31st of previous period. And our A is basically what we are adding, addition. And for the S, that's what we are subtracting. Our E represents our ending balance, right? So which means anytime you want to build your debt schedule, always keep this in mind. You need your beginning balance, addition, right? Subtracting and ending balance. So for this, instead of beginning balance, you always be closing balance for previous period. What are we adding? Definitely that will be our new loan. And what are we deducting? That will be our what? Our principal repayment. So keeping this in mind, let's go ahead and let's create a case study. So I'll make sure this is this is well simplified and right, and we definitely also make mistake that I know you typically make whenever you are building your own model. So you also understand that it is not a cast in stone. You are allowed to be flexible. So let's assume. So let me put this out. Let me call it our assumption. So let's have a list of assumptions here. We'll keep it simple, then we'll now take it advanced level. So let's assume we want to get a loan, right? Let's say this is our loan amount, and I'm just going to put everything in $1,000,000. So US, let me just put it like this. I think actually this is better, right? And how much? So let me put this form of my input so that we know that yeah, this is our hard coded value. So let's say we are going for a 500 million loan. And what's our period? So let's say the period, and this will be in year, and this will be for 5 years. So this is also a coded value. Put it like this, right? What other things? And let's assume they are giving us interest rates, which will be in percent, also be in input. And let's say they are giving us 15% per annum. So let's assume this is what I have. I'm going to get a loan of $5 million or period of 5 years and my interest rate of 15%. So which means I need to go ahead and build my debt schedule. Call this my debt schedule. Then I have my beginning balance. Then I have what I'm having, which is my new loan. Then I have what I'm deducting, which is my what? So which will be my repayment. Then I have my ending balance. Let me just copy this, our currency unit. Let me put it here. Right. Okay. So, and up here, we're going to have our period. So let me call this my period. In fact, let's put it up here so that it's easy for us to see. So this previous period plus 1. So always keep it in mind that whenever you are building your model must always have a base period. So let's just have like 5 years, right? Let me format this to show in form of a year. I believe we know how to do this. So let me just format it so that it shows year one. So I have it in this format. Okay, great. So let me just let me do a design work, right? Just to make it look good. Okay, and I can add my grid line. I don't like seeing the grid line. Okay, great. Okay, so it looks like this. Yeah, we are good. All right. So let's build out the layout of our schedule. Right, as I said, my beginning balance will always be the closing balance, but let me add one column here. Add one column here. Right, so structuring is very important whenever you are building your model. So beginning balance will be equal to closing balance of previous period, even if it's blank, 0, just leave it like that. All right, then my ending balance will be my beginning balance plus my new loan minus my repayments. Enter. So one of our financial modeling standard is saying whenever you are building your model, always make sure to keep everything uh, in the absolute value. So let me format this so that anything zero is showing as blank. Yeah, just like making my work look neat. So let's maintain one decimal. Then if it is zero, should just make it dash. Let me format it so show like that. Okay, great. So I said beginning balance is equal to closing balance for previous period, and our ending balance beginning balance plus new loan minus repayment. So I'm keeping everything positive. Anything we are deducting, instead of putting it into brackets, I'll put it in negative, and in my formula, I'll just put the deduction. Now, as I said, we're going to keep it simple at first. So let's assume new loan, right, is coming in this period. But a very good thing we can do is to come here and type. So as you are building your model, always think about flexibility, right? The flexibility of your model is very, very important, especially in project finance, because you get to one financial, they are telling you this or that, get another financial, they are saying this is this. So you build a model in such a way that the model will be able to answer any question anytime. So let's say inflow, let's say inflow period. Let me put this in here, right? And then you're saying the loan will come in year one. So the loan will come in year one. So in relation to this, we're now going to make use of what we call mask and flag, right? And what does it do? So one of our standards is also saying try as much as possible to reduce the use of your if function, especially nested if. So I'm going to call this our inflow flag, right? And I just want to use this to automate my loan inflow. So I'm going to say equal to my year that I've lifted here, listed up here, right? Are you equal to the loan inflow period that I have here, which I'm going to log the what? Just use absolute reference. Just lock it, right? $F $13. Now I'm going to press my enter, and it's going to give me either true or false, right? And I can copy that to the right. So people don't really like seeing this true or false instead. Some of us prefer to see 1 or 0. So I'll just type n function here, right, which converts a number to 1 or 0. So type my n in front of the formula and close it, enter, or you could just multiply it by 1 either way. Then I have this, right? So let me copy this, my format I created here, so that when it's 0, it's just make it dash. Okay, good. Then I'll come here for my new loan, just type equal to my loan, this is my mask, all right, then multiply by what this my loan amount that I have here. I'm also going to keep constant, press enter, and I can drag that for the period. Another way, another option you could use is to put this funding and put it under respective period. So there are times where you build a model and you might expect them to raise. So as I said, it's all about flexibility. Then I'll put it here, then make that one yes, the dash, and I can come here and just link it directly. So either way, but as I said, it's very flexible. Any style you want, you can always use that. Okay, so now that we have this, let's just go ahead and let's calculate our interest expense. Let's calculate our interest expense, right? And basically that will be, so I like making my model very flexible, well structured. So let me just link this my interest expense here, right? And I can put it maybe in brackets, maybe red brackets, so that it kind of shows that this is linked, right? Just you making that differentiation. Okay, so equal to open my brackets for the interest expense. We are going to try different method, but for this, let's just keep it simple. Beginning balance plus my new loan, right? Then multiply by my what interest expense, which I'm going to keep constant. I can drag that for the period. Then to calculate my loan, my repayment, right? Keeping everything simple. It's basically saying for my actual principal amount, hey, I'm getting this $500 million, and I need to repay it back over 5 years. So keeping that simple, let me sum this together here. Let me sum all this my total loan here. Right? Keeping it simple is basically saying I'm equal to this my loan, then divided by what? Divided by 5 years. Which means I'm going to pay you back this money, and what you are gaining in return is this interest expense. So keeping it right as this, if I drag this for the 5 years, you realize that at the end of the period, it will be fully repaid. Right? And you can see the variation in my interest expense. So keeping it simple, right, without using PMT formula or any kind of formula. This is what this is saying. But now, let's take a look at this. Let's assume we come back here and we're saying, oh no, our loan should be for 3 years. If I type 3 years here, look at the problem that comes up here. As I said, building that flexibility. So let me change this back to 5 years. Quite fine, everything is working well. But yes, some people use the main function, but let's also use that same flag, and let's call this one the payment flag. That building that flexibility is very important, and I'm going to say equal to, right, my year that I have up here. Are you lesser than or are you equal to our repayment period? So I'm going to lock, right, and I'll press my enter, and let me put my n in front of it, and open the brackets and close the brackets, enter, and drag that for the year. So I'll copy this and I'll put it here. So basically we now use this guy to restrict the repayment. So equal to, then this 100, I'm going to keep constant, multiply by my repayment flag and press enter. I can copy that for the 5 years. So the benefit of that is whenever the period loan is it will only be for 3 years. Come here, tap my 3 years, enter, and you see automatically this mask and flag just help us to restrict that payment and building that automation. Alright, so now let's take a look at another thing. Let's assume this is coming in year 2. Right, enter, and our repayment is 3 years. It's not that we are in for another problem, right? So let me undo, let me put this back. So as you are sorting one, you will also be seeing another one. So as you are building your debt fund, especially in project finance, you are thinking wider, right? You don't want to get to the client and client say, okay, what if the inflow period comes in year 2? Maybe equity will fund anything you need in year 1. Right, and they come to your model and they type 2 here and they just say everything just scattered. That means you need to go back and start, but you really don't have that time. So you must always build that into your model, right? So let me keep this back to what we have, and let's go and sort the first problem that we have. I'm going to duplicate this